For centuries, we assumed that barking, meowing, and neighing were just mindless emotional reactions to the environment. But everything changed this week when scientists successfully decoded how animals actually talk using advanced artificial intelligence. It turns out that the animal kingdom has been speaking in complex, highly structured sentences this entire time. We simply lacked the proper technological tools to translate their biological language until right now. Researchers recently fed millions of hours of animal audio into deep learning algorithms designed to spot hidden acoustic patterns. What they discovered completely shatters our fundamental understanding of biological intelligence. It proves beyond a shadow of a doubt that your pets actively try to communicate specific concepts to you every single day. How exactly did an algorithm finally break the barrier between human and animal communication when biologists failed for decades? It all comes down to bioacoustics and specific frequencies that the human ear cannot physically detect. For decades, researchers limited their studies to the basic sounds we could actually hear and record with standard microphones. The new AI systems, however, analyzed microscopic variations in pitch, tone, and overall rhythm across massive global datasets. It discovered that animals regularly pack immense amounts of data into split-second vocalizations that sound like a single noise to us. The AI isolated these microbursts and found that animals follow strict conversational rules, taking turns speaking and even adjusting their volume based on who is listening to them.
Let us look closely at canine communication as a prime example of this complex new grammar. A dog bark is not just a loud noise meant to show basic excitement or fear. The algorithm revealed that dogs combine high-frequency vocal microbursts with coordinated body language to form complete thoughts. They essentially use a combined physical and vocal grammar system to relay detailed information about their environment. They can actually specify if an approaching threat is large or small just by slightly altering the acoustic shape of a single bark.
Even more surprisingly, the AI decoded that dogs have specific names for their favorite humans and toys, using unique acoustic signatures that they only deploy when referring to those specific things. When a dog looks at a leash and barks, they are not just making random noise, they are using a specific noun. Furthermore, researchers discovered that dogs develop regional accents based on where they live and who they interact with. Your dog is actively mirroring your vocal cadences, trying to match the rhythm of your speech to create a stronger social bond.
These profound discoveries only become more fascinating when you look at animals we typically consider quiet. Horses, for example, often seem mostly silent to the casual, everyday observer. But when the AI carefully analyzed their subtle whinnies, snorts, and breathing patterns, it found something astonishing. Horses use subtle variations in their vocalizations to convey detailed information about their emotional state and their hierarchy in the herd. Because they are prey animals, their language evolved to be incredibly nuanced, so it would not easily attract nearby predators.
The algorithm successfully mapped these quiet sounds and found unmistakable grammatical structures that remain remarkably consistent across different breeds and environments. They are constantly whispering to each other, warning the herd about potential threats or signaling exactly when it is safe to rest. Furthermore, the AI proved that horses can recognize and vocalize about specific past events. They have distinct calls that reference previous positive or negative experiences with specific humans, meaning they possess an auditory memory that they share with the rest of the herd. They even use low-frequency rumbles that travel through the ground to communicate with other horses over vast distances without ever making a loud noise.
However, the most specialized and manipulative communicators discovered by the OI are sitting right inside your living room. When the researchers turned their algorithms toward domestic cats, the results were completely unprecedented. We always assumed a standard meow was just a generic sound demanding attention from the owner. Yet advanced acoustic analysis proves that cats do not actually meow at each other in the wild. They developed an entirely unique set of vocal frequencies specifically designed to trigger the human brain. They utilized dozens of distinct sounds for greeting, demanding food, and expressing anxiety.
They literally hack human psychology with highly targeted, specific sound waves. By analyzing the exact pitch of a purr or the precise length of a meow, the AI found that cats are effectively training us to respond to their specific biological needs. They even mirror the frequency of a human baby crying when they want to guarantee we get up and feed them. The purr itself is not just a sign of happiness, but rather a bioacoustic mechanism emitting frequencies between 20 and 150 hertz. The AI revealed that these specific frequencies actively promote tissue regeneration and bone healing in both the cat and the human holding it.
What happens now that we finally possess the dictionary to this hidden biological language? We are rapidly entering an era where genuine communication between humans and animals becomes a daily reality. You do not have to wait for software engineers to build a futuristic translation collar to understand your pets. There are proven methods available today to decipher these exact vocal frequencies and physical cues at home. If you want to master the specific vocal triggers that domestic felines use, there is a comprehensive communication guide linked below called Speak to Cat. It thoroughly breaks down the exact acoustic signals you need to understand what your cat is trying to tell you. The days of guessing what our animals are thinking are over, because they have been talking to us all along.